So whenever we are asked to find the limit, we always plug it in to check and see if it's a number or if it's an indeterminate case. So when I plug in here, from the right, so 1 over x, this is the graph of 1 over x. So obviously when x approaches 0 from the right, this expression goes to infinity. And now what happens when arctangent is applied to a value, let me call it y, that approaches infinity? So the graph of arctangent, I think we reviewed it sometime during the skills assessment, but maybe not. So the graph of arctangent is also, or the function is also bounded at above by pi over 2 and below by negative pi over 2. And here's the graph. It kind of looks like x cubed, but it's not a polynomial function. A polynomial function will never have horizontal asymptotes. So this is arctangent x. So when the argument of arctangent approaches infinity, so as x approaches infinity, the function arctangent will approach pi over 2. And b is when limit as x approaches infinity from e to x minus x squared. So again, I have to check and see what kind of indeterminate case this is. And I realized this piece will approach negative infinity when x approaches infinity, and e to negative infinity is 0. And you don't need to do anything else.
For the first one, would we just need to show that arctan 1 over x because...
No, you don't really. No, this is my explanation to you. This is very clear. You can just write directly pi over 2. But you have to show at least that this approaches infinity or something, that you tested. Yeah, but you don't have to graph.
Can we look at number 2 next?
Yes, of course. What does number 2 say? Yeah, it's finding the definition like we did last time. Do you really need that? I'm fine. So f prime.
Yeah. How do you review it? So.
Okay. It's the difference quotient with the limit in front. So you have to write as h approaches 0. From 4x plus 4h plus 1 over x plus h plus 3 minus 4x plus 1 over x plus 3 divided by h. We have to find the least common denominator. So this is the limit. H approaches 0. And this is x plus 3, x plus h plus 3. Watch me run out of time and paper on this one. I always do. Okay, so then this needs an x plus 3, and this needs an x plus h plus 3. Okay, so I redistribute x. So I have 4x squared plus 4xh plus x plus 12x plus 12h plus 3. Minus 4x squared minus 4xh minus 12x minus x minus h minus 3. And as we know, two things are mandatory, have to happen. All terms without h must go away. And maybe more, that's a bonus, that's fine. But all terms without h must go away. And they do. And the remaining terms are positive 12h minus an h, which is negative, positive 11h. And so this is over 1, so I flip it. Do not drop the limit operator till the very end. And this is h, x plus 3, x plus h plus 3. We simplify by h, and we get 11 over x plus 3 squared. So that is a derivative function for 4x plus 1 over x plus 3. Of course, the same condition, the same restriction, x not equal negative 3. The function is not defined at the point, so its derivative cannot be defined at that point either. Okay, anything else you'd like to go over?
Can you hold that there for just like another minute?
Say that again?
Can you just hold the paper right there for another
Yeah.
second?
Yes.
Can we do 5C?
Yes, 5C is next.
So in the first, like the one where you did all the distributions and the denominator, does that say x plus 3, x plus 8 plus 5?
X plus h plus 3, x plus 3. So when we replace x by x plus h, I have everything the same, just x plus h changes. Everything is 3. Everything is 3. Everything is 3.
Not like a 3.
Yeah, I'm writing on an angle like this. Yes, there is no 5 here. Yep.
Your camera just went out again.
I'm pushing something, I think. Probably, I see, it touches this cable here, that's why. Yeah, that's what it is. Okay. I don't understand why.
What question did we just do again?
We just did number 2, and your camera also went out again.
Yeah, I just saw that. I did that intentionally this time to see why it did that. Yeah, I can touch that cable. So yes, this was problem 2.
Okay, hold up 1 second. I wrote it for the wrong problem. That's why I was like asking. I was like, this don't look right. No, I didn't see it.
So moving on to 5C. Let's see what 5C is asking us to do. Where is 5C? That's 5. Oh, C. Oh, yes. We have limit as x approaches 2 from 2 minus x over the absolute value of 2 minus x. And the problem is asking us to fully simplify without the absolute value before we do anything. So let's do just that. So we take 2 minus x in absolute value. And we know there are 2 options. Is that okay now? Are we okay? Anyone? Okay. So then we have 2 minus x if 2 minus, minus x, 2 minus x is greater than or equal to 0. Is negative 2 minus x if 2 minus x is less than 0. And remember, we do not solve that. There is no need. We only solve the first one, which negative x greater than or equal to negative 2 reduces to x less than or equal to 2. Therefore, this is greater than 2. That is good, but it's not good enough. We want to simplify this. That's the function we are looking at. So if the denominator has 2 options, then the whole thing has to have 2 options. So 2 minus x over 2 minus x will be 1 for x less than 2, not equal to, because we cannot have 0 in the denominator. And the other option will be 2 minus x over negative 2 minus x, which would be negative 1 for x greater than 1. Greater than 2, of course. Since the limit is from either side, I have to write that the limit as x approaches 2 from the left of 1 is 1. And the limit as x approaches 2 from the right of negative 1 is negative 1. Therefore, limit as x approaches 2 from either side of the function f of x is DNE. But I have to show both, because the limit is determined from either side.
Where did the 1 and the negative 1 come from?
From here? I mean, where they came here.
Yeah, how did you get that?
I replace this by this. 2 minus x over 2 minus x is 1. Then I replace this by the other option. So I have negative 1.
You didn't plug anything in?
So I have two options for the denominator. When the denominator is the first option, I get 1.
Oh, okay.
When the denominator is the second option, I get negative 1.
Okay.
So if any of these, not the numerator is fixed, I cannot change it. But since the denominator has two options, then the final form of this will have to have two options.
Okay.
Is that better?
Yep. Thank you.
Thank you.
Did you go over number 11?
We will. Yes, of course. Any questions on this? Any questions? So because the limit is from either side, and I didn't plug it in, I should have said that, it's 0 over 0. We have to determine both sides. Okay. Number 11, yes? 10,
Yeah.
11. Okay, very good. So limit as x approaches 1, 1 minus 3x over 2 equals negative 1. I have to check. Negative 2 over 2, yes, that's correct. For every epsilon greater than 0, there is a delta positive such that 0 less than x minus 1 less than delta will always imply 1 minus 3x over 2 plus 1 less than epsilon. So we start at the end. Of course, I'll find the least common denominator inside the absolute value, 1 minus 3x plus 2. I meant to write epsilon, of course. As I said, what will I do without my whiteout? I didn't mean to write delta. Okay. So then it's negative 3x plus 3. I'll factor out negative 3. Then I write the property of absolute value. Now I change this into 3 and 2. And now I multiply by 2 over 3, which is delta. And in number 2, show that delta equals 2 epsilon over 3 works by reversing the steps. Reversing the steps.
You go through it a little bit slower.
Yes. I also recommend we have looked at several examples, and you have also videos on that. So which part you think I need to go back to? Because I don't really want you to look at just one example. That's why I'm referring back to the class notes. Which part I need to go?
No, I think I got it. I just had to finish copying it down.
Okay. I'll go back and go back step by step if you want, if you need that. Anyone? Questions here?
He just told it there for another.
Sure. Well, Prince and Mac, I can't see you, so I will remove you if If you cannot create a virtual background so I can see you.
My camera doesn't seem to be working.
That's
I'm not sure why.
That's not unusual. Look at my equipment. That's not unusual.
Same thing's happening to me.
Yep.
Hopefully it should be fixed by next time.
Okay, I
Sorry
understand.
about that.
That's fine.
If you don't have a webcam or it's not working, can you still do honor lock?
No.
I have a question.
I'm copying. Can we go to number 10?
Yes, number 10 is next. Yes, any question? Yes.
So it says that it says works at the bottom for step number 2. It says works, and then what's that beside it?
By reversing the steps from above.
Oh, it says by. Okay, that's all right.
By reversing the steps from above. No, honor lock is very, very strict. Very strict.